Let's see this question on electrolysis. A current of 4.5 amperes is passed through a solution of gold salt for 1 hour 45 minutes. Calculate A, the mass of gold deposited, B, the number of moles of gold deposited, C, if the same current is used. Find the time taken for 5.5 grams of gold to be deposited. The relative atomic mass of gold is 197. 1 farad is 96,500 coulombs. Okay, so what do we do? Let's list the givens. The current is 4.5 amperes. This is a current required for the electrolysis of gold. And the time it took is 1 hour 45 minutes. Remember, 1 hour is 60 minutes plus 45 minutes. And it gives us 105 minutes. Now, the unit of time is second and not minute. So we are going to convert to second by saying 105 minutes times 1 minute. And inside 1 minute, we have 60 seconds. So 105 times 60 seconds will is going to give us 6,300 seconds. This is the amount of time required for the electrolysis. Now, the A question says the mass of gold deposited. That is what we are asked to calculate. But remember, the equation of electrolysis is that gold ion, which has 1 plus, accepts 1 electron to be reduced to gold atom. Now, you could see that since 1 electron was liberated by 1 gold atom, it means that we have 1 mole of electron. And this 1 mole is liberated by 1 farad. And 1 farad liberating 1 mole means that it is also liberating 197 grams. Because 197 grams is the mass contained in 1 mole of gold. Okay, so, but recall that 1 farad is equal to 96,500 coulombs of electricity. And this amount of charge is the one that deposited this gram. So we can say that 96,500 coulombs deposited 197 grams of gold. But remember, quantity of charge is the product of current and time. So the current involved is 4.5 amperes. So this 4.5 amperes multiplied by the time is 6,300 seconds. You are going to get 28,350 coulombs. This is the amount of charge required in the electrolysis. This is the amount of charge involved in the electrolysis. So now, if 96,500 coulombs deposits 197 grams of gold, this means that 28,350 coulombs would deposit X grams of gold. So to find this X, we run the proportion by saying that 96500 divided by 197 is the same thing, is in proportion to 28350 divided by X. So when we clear the fraction, 96,500 times X equals 197 times 28350. So 96,500X will give us 96,500X will give us 5 million. If you multiply this to 5,584,950. So making X the subject, we have 5,584,950 divided by 96500. If you divide the two, you are going to get 57.9 grams of gold deposited. So this is the A part of the question. That is the A part of the question. B part says number of mole. And you know that number of mole means mass over molar mass. That is the formula for number of moles. But in this case, number of moles of gold deposited is the mass deposited divided by relative molecular mass of gold. So the mass deposited in this case is 57.9 grams. When you divide it by relative molecular mass of gold, you are going to get 0.3 mole. So that is the B question. Now the C question says if the same current is used, we should calculate the time taken for 5.5 grams of gold to be deposited. So how do we do that? We recall that 57.9 grams was deposited. It was deposited by the quantity of charge, and that quantity of charge is 28,350 coulombs of electricity. Therefore, 5.5 grams would be deposited by what? Let's say Y coulomb. So we are going to find that Y. By proportion, we can say that 28,350 divided by 57.9, or 57.9 divided by 28,350. Anyone will give you, because we chose here first. We go here now. Y divided by 5.5. So to find Y, we clear the fraction. 57.9Y will give you 5.5 times 28350. So having got that, we can say that 57.9Y will give us, if you multiply these two, you are going to get 155,925. So Y will give us 155,925 divided by 57.9. We are going to get 2,693 coulombs of electricity. So this is the amount of electric charge, amount of electricity the coulomb required to liberate 5.5 grams. But we are trying to calculate the time required. So that is why you should recall that the quantity of charge is equal to current times time. And we are looking for time. So time will give us quantity of charge over current. And in this case, the quantity of charge is 2,693. And the current, they say if the same current is used, which is still 4.5, if you divide these two, you are going to get 598 seconds. That is the time required to liberate 5.5 grams.